Welcome to another video. Today we're going to follow up from a previous video on the pulley on a table system. But this time we're going to look at GeoGebra, and we're going to analyze its motion through GeoGebra. But first of all, what we've got to do is re-look at our scenario. So this time we've generalized MA and MB. Remember that we can also think of FAB and FBA, or the force on A due to B, and so forth, as the tension force on the string from each respective different distance. Sorry. So it's like the pull from MA on B and vice versa. Okay. I'm going to set you up with a few key formulas from last video. It's an important recap as to what happened in the last video. So the acceleration total on that whole system was just the mass of A on the sum of both masses times by the acceleration due to gravity. The tension, which is also, as we talked about, equal to the magnitude of force of A due to B and B due to A, was the MA times MB on the sum of MA plus MB times G. And the F net was MA squared on the sum of both the masses times G there. Okay, so they're the formulas I used when creating this GeoGebra presentation that I'll show you in a sec. And also I did use some Suvat equations of motion to actually demonstrate the physics of the motion as it's sliding along here. So you should see some nice flow of these blocks left and right, up and down. So here you can see that there's no initial velocity, so these equations of motion simplify to those there. Okay, so let's have a look at this. This is the GeoGebra scenario that I've set up. You can see time is 0. I'll later change time. You've got M1 and M2. What I'm doing here is we had M mass of 2 just set as 3. As we increase mass 1, we can see the force of gravity increasing. When they're equal, the tension is actually half the gravity force. So the net force in each will actually be equal. And as we increase M1 here, we can see the force of gravity increasing and the tension slightly increasing also. As we decrease mass 2, so make it smaller and smaller, the tension's less, because that means I guess M1 doesn't have to pull down as hard on to pull M2, and we can see also the acceleration increases as well. Okay, so this is when M2 doesn't exist, or it's 0 kilos. This is just the acceleration due to gravity. So it is in slow-mo, so it doesn't look like real life. Just 1 second's passed there. And in 1.27 seconds, we've gone a distance of 8 meters roughly. Okay, let's have a look at another scenario. So here, the masses are equal, and you get an acceleration that's half of 9.8 in this scenario here. Cool. This was the scenario in the previous video that we had a look at. As you can remember, tension force was 7.84 newtons. The force of gravity is a little bit bigger, and we don't get very far in that in a certain time here. This next video, so we're going quickly through these. The M1 is a lot bigger. So we've got nearly the full 9.8 meters per second squared as the acceleration, and it's M2's only tiny, so it's only got a little bit of mass there. Okay, in this final little snippet here, we're going to see what happens. So time equals 1, and we're going to have a look at what happens. So if the mass were to increase, where it would be after 1 second. So it's another way of looking at it. I guess the bigger that mass is relative to mass 2, mass 1 relative to mass 2, the further or the higher the acceleration we get there. So as you can see here, the acceleration gets down to 9.8 meters per second squared. And at 1 second, the velocity is actually equal to that as well. And you get half the 4.9 meters there after 1 second. Cool. Short little video. Thanks for watching. I'll put in the link for you guys to have a look at. It'll be, I'll put the link so you can have a play around with this Geogebra app. But yeah, thanks for watching today. I hope it was a really short video, this one, but I hope you got a bit out of it in terms of understanding the physics or the motion of that particular pulley on a table scenario, or with the 2 blocks. Thanks again in advance for subscribing. It's really much appreciated. And I'll keep putting up these videos if you guys subscribe, and keep watching these. Definitely add some comments, add some questions. I can explain how I've done the Geogebra app a little bit more. But yeah, it'd be fantastic to hear your feedback there. Cool. Yeah, I'll catch you guys next time. See you later.